Here we're going to look at the concept of oxidation states or oxidation numbers. Oxidation states are very, very useful for helping us figure out what's going on in a redox reaction in terms of what has been oxidised and what has been reduced. I've given you the definition of oxidation state. It's one that you'll hardly ever need to actually know, but it is something I'm asked quite frequently, what is actually meant by oxidation state. It's how we assign oxidation states that we're going to look at in this video. And there's a certain set of rules that we need to look at when assigning an oxidation state. The first rule of assigning oxidation states is, and I'm going to shorthand for OS for oxidation state of an element is always 0. So for example, magnesium, chlorine, phosphorus, silicon, and so on, the oxidation states are always equal to 0. Second rule for assigning oxidation states, the oxidation state of a simple ion is always equal to charge of the ion. Simple ion being an ion with just one element, one type of atom. So for example, if I've got a magnesium 2 plus ion, the oxidation state there is the charge, that is +2. Chloride ion, oxidation state there again is equal to the charge -1, and so on. Rule 3, the oxidation state of fluorine in compounds is always equal to -1. And if you look at the definition, then fluorine being the most electronegative atom, if we just have a look, it's the charge the atom would have if the most electronegative atom owned all the bonding electrons. Well, fluorine is the most electronegative atom. It will always own all the bonding electrons, and as such that means we'll always have a charge of -1, or in this case an oxidation state of -1. Let's look at rule number 4. The oxidation state of oxygen in compounds is nearly always -2. There are a couple of exceptions, so that is except when oxygen is bonded to fluorine or in peroxides where we've got this structure here, an O with a single bond O. So they're the first 4 rules when assigning oxidation states or oxidation numbers. Rule number 5 is the oxidation state of hydrogen. As I said, it should be in compounds, is usually +1. The exception being except when bonded or combined with metals. Rule number 6, the sum of the oxidation states in a neutral compound must equal 0. So for example, consider we've got water. Now we know from rule 4 the oxidation state of oxygen is -2, and from rule 5 the oxidation state of hydrogen is +1. Well, we've got 2 times +1 plus -2 from the oxygen, and that has to then equal 0. So the sum of the oxidation states of a neutral compound in a neutral compound must equal 0. Rule number 7. The sum of the oxidation states in a complex ion is equal to the charge on the ion. So for example, if I've got a hydroxide ion, you know that hydroxide ion is an OH minus ion. Well, we've got an oxygen at -2, hydrogen at +1, that's following rules 4 and 5, and therefore -2 + 1, that gives me the charge on my ion, and that is equal to -1. In the next video, we'll take a look at some more examples of rules, applying rules 6 and 7. I just will say that when we're looking at sort of rules 4 and 5, we're looking at elements sort of like hydrogen, oxygen, and then even stuff like fluorine. We're looking at things they're called fixed oxidation states. The oxidation states there don't change. And what we'll look at in the next video is how we can use these fixed oxidation states to assign the oxidation state of an atom which has a variable oxidation state.